Our focus for this video is implicit differentiation. Before I show you how to do implicit differentiation, there is a couple of rules that you need to remember. One of them is the power rule. Now, the power rule states that if you have a function which is y equal to x raised to some power which is n, and you are asked to differentiate this function with respect to x, then dy by dx is equal to nx to the n minus 1. What is this saying? This is saying that to differentiate a function of this form, you take the power to multiply by the coefficient of x and subtract 1 from the power. And let me show you an example quick. Let's say you have a function which is y equal 3x cubed plus 4x squared minus 3x minus 1, right? And you are asked to differentiate this. Then dy by dx is equal to 9. The derivative of 3x cubed would give you 9x squared plus the derivative of 4x squared would give you 8x, and the derivative of minus 3x would give you minus 3. The derivative of a constant always equal to 0. And that's how you would use the power rule. Another rule that you need to remember is the product rule, right? So the product rule is another rule that you need to remember. Now the product rule says that if you have a function, if you have two functions, right? Y is equal to a function f times g. And they are asked to differentiate this function. Then dy by dx is equal to the differential of the function f times g plus f multiplied by the differential of g. That's basically it. Now, let me show you an example. Let's say you have a function which is y equal x squared sine x. And you are asked to differentiate this function using the product rule. Then dy by dx is equal to, differentiate the x squared, you get 2x. Keep the second term, which is sine x, plus keep the x squared term now, which is x squared, differentiate sine x, that gives you cos x. And that's it. And that's how you would apply the product rule to a function, right? Now, another rule that you need to bear in mind is the chain rule, right? And the chain rule states that if you have a function which is y equal to ax plus b in bracket always to the n power, and you are asked to differentiate this function, then dy by dx is equal to n bracket ax plus b to the n minus 1 times the differential of inside of the bracket, which is a. Note here, a and b and n are integers, right? Now, let's say you have a function y, which is equal to 4x squared minus 3, all of that in bracket raised to the third power, right? And you are asked to differentiate that. Then dy by dx is equal to 3 open bracket 4x squared minus 3 to the second power, because if you subtract 1 from 3, that gives the second, times the differential of inside of the bracket. If you differentiate 4x squared, that gives you 8x. Differentiate minus 3, that gives you 0. So that's it. And that's how you would use the differential of the chain rule. Alright? Now, let's move into this example that we have on the board here. Now find dy by dx if x squared y plus y squared is equal to x cubed. So we have x squared y plus y squared is equal to x cubed, right? And you are asked to differentiate this implicitly. What you are going to do is to differentiate both sides of the equation with respect to x. So we are going to differentiate both sides of the equation with respect to x. So it's going to be differential of all of this side, which is x squared y plus y squared in bracket equal to the differential of x cubed. Right? Now this you can view this as you are distributing this d by dx to each term. So you could write it like this as the differential of x squared y plus the differential of y squared is equal to the differential of x cubed. Right? Now, note x squared y here is a product, so we have to use the product rule to differentiate this term. If we use the product rule, d by dx, so if we use the product rule to differentiate this term, if we differentiate x squared, that gives us 2x y plus, keep the x squared, differentiate y, we get dy by dx. Now plus differentiate y squared, that gives you 2y dy by dx equal to differentiate x cubed, that gives you 3x squared. Now what you're going to do is to group all the terms with dy by dx on one side of the equation and the other terms on the other side of the equation. So that means I want to get rid of this positive 2x y, so I need to subtract 2xy from both sides of the equation, and this side I left back with x squared dy by dx plus 2y dy by dx equal to 3x squared minus 2xy. Remember that we are solving for dy by dx. So what am I going to do here? Dy by dx is common to both terms. That means I can factor out dy by dx. So if I factor out dy by dx, then this left me back with x squared plus 2y equal 3x squared minus 2xy. Right? Now I want dy by dx by itself. I have to divide it by x squared plus 2y. So if I divide both sides by x squared plus 2y, divide this side by x squared plus 2y, then x squared plus 2y cancel out x squared plus 2y. So dy by dx is just equal to 3x squared minus 2xy, all of that divided by x squared plus 2y. And that's it. So let's just look at the second example. Second example says, find dy by dx if x squared plus y squared equal 9. Now again, we're going to differentiate both sides with respect to x, so it's going to be d by dx of x squared plus y squared equal d by dx of 9. Now, if you differentiate each term with respect to x, if you differentiate x squared, that would give you 2x plus differentiate y squared, that gives you 2y dy by dx equal, differentiate 9, you get 0. So I need to subtract 2x from both sides. That means 2y dy by dx is equal to minus 2x. Now I need to divide both sides by 2y, since 2y is multiplying this dy by dx, and I want to get rid of the 2y. So I divide this side by 2y, and I divide this side by 2y. Therefore 2y cancel 2y, dy by dx is equal to 2 cancel out 2, so that just leaves me back with minus x over y. And that's it. Let's do number 3. So we have number 3. So find dy by dx of 7x squared y plus 3x y squared equal 8y cubed. Now all you need to do is to differentiate both sides of the equation. So anytime you're differentiating a function implicitly, you just differentiate both sides with respect to x. So if you differentiate this side, it's going to be d by dx of 7x squared y plus 3x y squared in bracket equal to d by dx of 8y cubed. Now you're going to use the product rule to differentiate the first term. So if you differentiate 7x squared, that's going to give you 14x. Keep your y plus, keep the 7x squared this time, which is 7x squared. You differentiate y, that gives you dy by dx plus differentiate 3x y squared. You have to use the product rule. So you differentiate 3x, that gives you 3. You keep the y squared. Now plus, you keep the 3x. You differentiate. If you differentiate y squared, that gives you 2y dy by dx, which is equal to, differentiate 8y cubed, that gives you 24y squared dy by dx. Alright? Now what we want to do is to group all the terms with dy by dx on one side of the equation. Right? So here, as you can see, that we have 1, 2, 3 terms with dy by dx. So that on one side of the equation. Right? So since I have 24y squared dy by dx on this side, it means that I can subtract 7x squared dy by dx from both sides of the equation, as well as subtract 3x 2y dy by dx from both sides of the equation. Now if I do that, on this side of the equation, I will left back with 14xy, right, plus 3y squared, right, is equal to 24y squared dy by dx, right, minus all of this term here, minus 7x squared dy by dx, minus all of this term here. Now note that 3x2y can be multiplied to give you 6xy, so it would be minus 6xy dy by dx. Right? So that's it. What you need to do now is to factor out dy by dx out of each of these terms. So you'd left back with on this side, which is going to be 14xy plus 3y squared equal, open bracket. Well, I'm going to factor out dy by dx, right? So this, I could write dy by dx, open a bracket. Now, if I factor dy by dx out of this term, it leaves me back with 24y squared minus 7x squared minus 6xy. All of that in bracket. I want dy by dx by itself. All I need to do is to divide this side and this side by 24y squared minus 7x squared minus 6xy. And I also have to divide this side by 24y squared minus 7x squared minus 6xy. Now 24y squared minus 7xy squared minus 6xy squared, all of that going to cancel out all of the denominator here, which left me back with dy by dx equal to 14xy plus 3y squared, all of that divided by 24y squared minus 7x squared minus 6xy. And that's it. We only have one more example to solve, so let's just go straight into it. The last example says find dy by dx if 2xy minus 3y equal x cubed. Again, you're going to differentiate both sides with respect to x. So differentiate this side with respect to x. So that would give you 2xy minus 3y, all in bracket, equal to d by dx of x cubed. Now, again, 2xy is a product, so you have to use the product rule to differentiate 2xy. So using the product rule to differentiate 2xy, to differentiate 2x, that would give you 2, and keep the second term, which is y, plus, keep the first term, which is 2x, differentiate y, that gives you dy by dx, minus, differentiate 3 minus 3y, that would gives you 3 dy by dx equal, differentiate x cubed, that gives you 3x squared. Now all you need to do is to group all the term with dy by dx. So I'm going to subtract 2y from both sides. If I subtract 2y from both sides, I left back with 2x dy by dx minus 3 dy by dx equal to 3x squared minus 2y. Now all I need to do is to factor out dy by dx because it is common to both terms. If I factor out dy by dx, this left me back with 2x minus 3 equal to 3x squared minus 2y. Divide both sides by 2x minus 3. So divide this side by 2x minus 3. Also divide this side by 2x minus 3. Then 2x minus 3 cancel 2x minus 3. So dy by dx is equal to 3x squared minus 2y. All of that divided by 2x minus 3. And that's how you would differentiate a a function using implicit differentiation. Thanks for watching, and I hope that you will have a wonderful day.